Have you ever wondered, why do scientists deliberately blur the images of stars instead of capturing them in sharp detail? It may sound paradoxical, but this very blurriness is opening the door to discovering Earth-like planets beyond our solar system. That is also what CHOPS, the European Space Agency's latest satellite, is doing with its mission to search for worlds that may harbor life. If you want to uncover this fascinating secret and understand why blurry images could change the way we search for life in the universe, make sure to watch the video until the end. Don't forget to subscribe to the channel so you won't miss the next magical scientific journeys. If we look back at humanity's journey of exploring the universe, perhaps one of the most important turning points is the discovery of exoplanets, worlds orbiting stars other than the Sun. Today, hearing news about a new planet outside the solar system may sound quite familiar. But just imagine, only a little more than 2 decades ago, humans were not even sure that any planets existed beyond our system. We could imagine them, write science fiction novels about them, but scientific evidence was completely absent. That turning point came in 1995 when two Swiss astronomers, Michel Mayer and Didier Queloz, announced a historic discovery: the planet 51 Pegasi b, or more familiarly known as Dimidium. This is a giant planet belonging to the group of hot Jupiters, located about 50 light years from Earth. This discovery not only earned them the Nobel Prize in Physics later, but also opened up an entirely new field of research: exoplanet science. What is astonishing is that this first planet was very different from our Earth. Dimidium is a giant ball of gas orbiting extremely close to its parent star, with a period of only a few days. That means its surface is unimaginably hot, but this very difference made it easier to detect. When a planet has a large mass and orbits close to its star, its gravity is strong enough to make the star wobble, like swaying around a balance point in space. By observing this subtle wobble through the radial velocity method, scientists could confirm there is indeed a planet present there. That may sound simple, but in reality, it is incredibly complex. Remember that a star is usually millions of times brighter than a planet orbiting it. If you try to observe with a regular telescope, all you see is the blinding light of the star, completely hiding any small celestial body. Even with the nearest stellar system, Alpha Centauri, only 4 light years away, we still cannot directly see any planets by ordinary observation. This shows the enormous challenge scientists face. If detecting a planet right at the gateway of the universe is already that difficult, then how hard will it be to hunt for worlds tens or even hundreds of light years farther away? To overcome that barrier, astronomers had to come up with entirely new strategies. In addition to the radial velocity method, another technique has proven remarkably powerful: the transit method. Instead of trying to see the planet, scientists monitor the light emitted from the star. When a planet happens to pass in front of the star from our point of view, it blocks part of the light. This effect is like a small eclipse, making the star appear a little dimmer. And with just this tiny change in brightness, scientists can infer the presence of a planet, even calculate its size and orbit. This is precisely why the CHOPS mission has become so important. Launched by the European Space Agency ESA at the end of last year, CHOPS is not a giant telescope like Hubble. Instead, it is much more modest, only about 1.5 meters wide, with a 32 centimeter diameter reflecting mirror. But don't let its size fool you. This tool was designed with a very specialized goal: not to search for thousands of new planets, but to study in detail the planets already discovered. In other words, CHOPS is like a doctor running blood tests, examining the inner makeup of planets rather than just detecting their existence. And here comes the most intriguing part: the images CHOPS sends back are blurry. If you look at the first photos, you'll see that every star is smeared with light, unclear, and absolutely no trace of any planet. At first glance, many people might think it's a technical error, that the satellite malfunctioned. But in reality, it's the opposite. This is exactly what the designers intended. Why is that? Because to accurately measure the extremely small changes in light when a planet transits, what matters is not the sharp image of the star, but the distribution of its light on the sensor. When the starlight is blurred and spread across many pixels, scientists can measure changes in brightness with much greater sensitivity. In other words, a blurry image actually helps us see more clearly the incredibly tiny changes, and those changes carry the secrets of the existence and properties of exoplanets. This is a clever strategy. Instead of trying to take a clear picture of a planet dozens of light years away, something almost impossible with today's technology, CHOPS focuses on decoding the light from the star to find indirect clues. Thanks to this approach, it can study even the smallest known planets, called super-Earths, planets only slightly larger than Earth, or the size of Neptune. And it is in this group of planets that the chance of finding worlds that could harbor life becomes brighter than ever. One of the greatest challenges in the hunt for exoplanets is their extremely small size. If giant, scorching planets like Neptune are still loud enough to cause a clear wobble in their parent star, then Earth-sized planets are almost invisible. Their influence is so weak that the signal is drowned out by the star's brilliant light. That is why small planets, which are top candidates in the search for life, become some of the most difficult targets to study. And this is where CHOPS demonstrates its unique role. Equipped with an ultra-sensitive photometric system, CHOPS can measure subtle variations in starlight that other telescopes can hardly detect. Not only can it identify when a planet passes in front of its star, CHOPS can also track the phase curve of that planet. Put simply, the phase curve is the change in the amount of light a planet reflects as it moves around its orbit. When the planet passes in front of the star, the light decreases. When it shifts to the side, the reflective surface becomes larger, making the star appear slightly brighter. And when the planet slips behind the star, the reflected light disappears completely. Each of these stages leaves traces in the data collected by CHOPS. If scientists know how to read those traces, they can not only determine the orbit or size of the planet, but also analyze the composition of its atmosphere. How important is this? Imagine if a planet reflects light with the signature of water vapor, methane, or even oxygen, that could be an indication of conditions for life. Although we still cannot confirm the existence of life out there, detecting an atmosphere similar to Earth's is an indispensable step toward answering the biggest question: are we alone in the universe? However, the next question arises: why send a device like CHOPS into space? Can't we place a giant telescope right on the ground and perform these measurements from Earth? The answer is, it's not that simple. Earth, where we live, is also an environment that obstructs precise observations. The first barrier is the cycle of day and night. Within 24 hours, half of the time we are covered by sunlight, making it impossible to observe stars. This means that scientists may miss extremely important events, such as the moment a tiny planet passes in front of its parent star. If that event lasts only a few hours but happens to fall during the day, the opportunity is lost. Even at night, things are far from ideal. When light from a star dozens of light years away travels to Earth, it must pass through the entire dense atmosphere. Along the way, photons collide with countless molecules of gas, water vapor, and dust. As a result, the light reaching the telescope is distorted, flickering, shimmering, a phenomenon we often see with the naked eye as stars twinkling. Beautiful as it may be, for scientists, this twinkling is a nightmare because it distorts measurement data. Of course, scientists have devised many ways to mitigate this, from placing telescopes on high mountain peaks to reduce atmospheric effects, to using adaptive optics technology to correct the image. But no matter how sophisticated, these methods cannot compare with removing the atmosphere entirely from the equation. And there is only one way to do that: put the telescope in space. That is why CHOPS was placed in a sun-synchronous orbit about 700 kilometers above Earth. At this position, it moves along the boundary between day and night on Earth, continuously illuminated to operate on solar power while maintaining a stable view into the deep universe. No longer interrupted by day and night, no longer blurred by the atmosphere, CHOPS can make continuous, precise measurements sensitive enough to detect light changes as small as 1,000th. This opens up an unprecedented opportunity, not only to detect the presence of small Earth-like planets, but also to decode their atmospheres. This is the crucial step in distinguishing between a barren rocky planet and a world that could sustain life. In other words, CHOPS is not just a scientific tool, it is the eye that helps humanity take another step forward in the journey to find a second home in the vast universe. The fact that CHOPS was placed into a sun synchronous orbit is not just a technical choice, but also a wise scientific strategy. In this special orbit, the satellite flies along Earth's day night boundary, where sunlight always reaches its rear to maintain power for the solar panels. At the same time, its eyes facing outward into space avoid interference from direct sunlight. This allows CHOPS to operate non-stop, observing stars 24 hours a day, 7 days a week, without being hindered by Earth's day-night cycle. This means that for each observation target, CHOPS can collect a continuous, uninterrupted stream of data. This is the decisive factor in detecting the tiniest changes in starlight, faint but precious signs of exoplanets. With gigabytes of data transmitted daily, we are facing the prospect that it is only a matter of time before a truly Earth-like world is confirmed. Imagine a rocky planet with a mass similar to Earth orbiting its parent star in the habitable zone where temperatures are just right for liquid water to exist. If its atmosphere contains oxygen, water vapor, or even traces of methane, potential indicators of life, then this discovery would be a historic turning point. It would not only be a triumph of astronomy, but also a milestone that changes how we see ourselves. Because the question, are we alone in the universe, is not merely a scientific question. It is also a philosophical one, an existential drive that has haunted humanity for thousands of years. From the ancient Greek philosophers to modern science fiction writers, humans have always pondered the possibility of other worlds, where intelligent beings may exist, or at least some form of simple life. CHOPS is one of the first tools that can bring us closer to an answer. If one day CHOPS's data confirms a planet with Earth-like conditions, we will have to face many fascinating consequences. First, it will change our view of Earth's uniqueness. Our blue planet may not be a rare exception in the universe, but just one of many blue gems scattered across the galaxy. This possibility not only raises hopes for extraterrestrial life, but also prompts the question, could there be civilizations that have existed, are existing, or will exist alongside us? On the other hand, such a discovery would also directly affect how humans perceive their own future. In the context of climate change and other global challenges, the idea of finding a second home has become a powerful driving force for both science and technology. Of course, even if a planet with ideal living conditions is discovered, migrating there will remain out of reach for centuries to come. But simply knowing that such a world exists is enough to spark imagination, drive technology, and even shape humanity's political and social decisions. Moreover, the mission of CHOPS goes far beyond the search for a second Earth. Each planet it analyzes will provide valuable data about the diversity of worlds in the universe. Some planets are barren, some shrouded in toxic atmospheres, some frozen in ice. This diversity is the puzzle piece that helps us better understand how planets form, evolve, and interact with their parent stars. From there, we can compare and contrast to see just how special our Earth really is. What is interesting is that although CHOPS is small compared to giants like Hubble or James Webb, its specialization is what gives it strength. It is not a Swiss Army knife to observe everything, but rather like a finely tuned microscope focusing on a single target, exoplanets. This focus allows it to achieve outstanding precision in its field. And in science, sometimes a small tool designed with the right purpose can make discoveries that change all of human knowledge. When looking at the blurry images CHOPS sends back, one might think they are just low-quality pictures. But hidden behind that haziness is a vast treasure of data. Each twinkling light, each tiny fluctuation contains the story of distant planets, of atmospheres, of the existence or non-existence of life. And over time, each piece of data will be assembled into a more complete picture of the universe we live in. Therefore, the mission of CHOPS is not just a scientific project. It is also a journey of human curiosity, a testament to the never-ending desire for discovery. Every signal it captures from the depths of space is a reminder that we are only at the very first steps of an endless path. And who knows, perhaps among that data lies the answer to the oldest question, are we truly alone in the infinite cosmic ocean? When we look up at the night sky, the only thing separating this tiny Earth from the rest of the universe is a vast black canvas dotted with stars. Yet hidden behind that shimmering beauty lie questions that have never ceased to haunt humanity. Where did we come from? Are we alone? And are there other worlds out there waiting to be discovered? The birth of Chops is the proof of that eternal longing, the longing to find answers to mysteries beyond imagination. For thousands of years, humankind could only speculate. Ancient civilizations created myths to explain the twinkling lights in the sky. In the modern era, we use telescopes to realize that those stars are actually other suns, and many of them might have planets orbiting around. Yet it was not until the arrival of specialized instruments like CHOPS that humanity truly had the chance to hear the whispers of distant worlds. The wonder of CHOPS lies not only in its technical capabilities, but also in the long-term vision it opens. Every light signal it collects, every tiny fluctuation in a star's brightness, is a piece of the puzzle contributing to the larger picture. We may not find a second Earth tomorrow, but it is this patience and continuity that gives science its value. Just as a seed needs time to sprout, the data from CHOPS needs time to gradually reveal a greater truth. And when that truth appears, it will not just be breaking news in astronomy. It will be a moment that redefines humanity's place in the universe. If there is another Earth-like planet, then life, at least in its simplest form, may not be a rare phenomenon. Life itself could even be a universal rule rather than an exception. This idea is both overwhelming and comforting, that our existence is not a unique accident, but may be part of a greater tapestry. On the other hand, suppose CHOPS continues to operate for years without discovering any Earth-like world, that result would still not be meaningless. For even the absence of suitable exoplanets carries a powerful message. Earth is truly special, a rare gem in the cold universe. This reminds us to cherish and protect our own planet because we cannot yet be certain that we will ever find another to replace it. Whatever the outcome, CHOPS has helped affirm one thing. Exploring the universe is not a luxury, but a necessity for humanity. Every step forward in this field brings a series of technological advances, from imaging sensors and communication systems to artificial intelligence for data analysis. These technologies then circle back, improving our daily lives on Earth. Space science, therefore, not only broadens horizons, but also directly contributes to social development. On a deeper level, CHOPS also reminds us of humanity's unity. The universe does not care about national borders, languages, or skin color. A discovery of an exoplanet, if it happens, will be a discovery for all of humankind. It will not belong to one country or one organization, but be the shared heritage of us all. This carries an important message. When faced with the greatest questions, we can only find answers by working together, overcoming small divisions. Imagine a scenario in the coming decades when data from CHOPS and its successors allow us to map in detail hundreds or even thousands of distant worlds. Among them will be gas giants like Jupiter, icy worlds like Neptune, and perhaps some small rocky planets brimming with potential. That vision will not only change how scientists work, but also how ordinary people like us look at the night sky. Because from then on, when we lift our heads to the stars, we will not just see lifeless lights, but know that orbiting them are planets, unnamed worlds, possibly harboring life. And that thought alone is enough to turn every dark night into an invitation, a whisper urging us to keep exploring. Ultimately, perhaps CHOP's greatest value does not lie in what it discovers, but in how it stirs our collective imagination. It reminds us that no matter what achievements humanity has reached on Earth, from modern technology to complex social networks, we are still only taking our first steps on the cosmic journey. Ahead lies an infinite ocean of stars, and our mission is to keep venturing forward, knowing it may take generations before answers are found. So, whenever you hear about CHOPS or see the blurry images it sends back, don't think of them as just the work of distant scientists. See them as part of humanity's shared story. The story of an endless desire to explore the universe and understand ourselves. And who knows, one day in the future, when a signal confirming the existence of an Earth-like planet is announced, you may look back to this very moment and feel proud that you lived in the era when humanity began to cross the threshold into the cosmos, carrying with it the age-old but weighty question, are we truly alone in the universe? Perhaps when we mention CHOPS, we are not only talking about a telescope or a specific mission. We are talking about a symbol of humanity's aspiration to go beyond the finite boundaries of this planet. Throughout history, from the moment humankind first gazed upon the Milky Way with the naked eye until now, every step forward in astronomy has been tied to great advances in civilization. CHOPS is just a new link in that long journey, but it carries within it a potential great enough to change how we define home. Because if one day data from CHOPS helps us discover a rocky planet with an oxygen-rich atmosphere, signs of liquid water, and suitable temperatures, then the word home will no longer be confined to Earth alone. It will expand, encompassing distant worlds we have never set foot on. This does not mean that we will forget Earth. On the contrary, realizing that this planet may be one of the very few rare paradises will give us even more reason to protect it, to live more responsibly toward the environment and future generations. CHOPS, in a sense, is like a bridge. One end of the bridge connects to science, numbers, graphs, light spectra, and precise measurements. The other end connects to emotions and imagination, the yearning to find life, or at least to find a reflection of ourselves in the vast universe. Walking on this bridge, humanity is at once a rigorous scientist, a dreaming poet, and a philosopher asking, if there is other life out there, how would the meaning of our existence change? In reality, many people often think astronomy belongs only in laboratories, to scientists with giant telescopes and complex algorithms. But CHOPS reminds us that the universe belongs to everyone. When you look up and see a twinkling star, you are sharing the same sky with billions of others. You are looking toward the same direction that CHOPS is observing. And somewhere, in every photon of light, there may be hidden the answer to the eternal question, are we alone? That question is both simple and profound. It carries fear, because if we are completely alone, then the responsibility of protecting life becomes a tremendous burden. But it also carries hope, because if civilizations exist out there, then perhaps we will never have to be alone on our journey of discovery. CHOPS does not promise to give us the answer immediately, but it gives us the tool to move gradually closer to the truth. Imagine, 50 years from now, when technology has advanced further, humans may be able to send unmanned spacecraft to exoplanets discovered by CHOPS. The first close-up images of another world with oceans, a blue sky, and drifting clouds will be transmitted back to Earth. That moment will be a milestone not only for science, but for the whole of civilization. And you, living in the present, may be able to tell your grandchildren, I once lived in the era when the very first steps of that exploration were taken with a satellite called CHOPS. That is the beauty of science, not only to serve the present, but to sow seeds for the future. Every measurement of light, every blurry photo that CHOPS sends back may seem like just a small piece of data, but when pieced together, it becomes a legacy for many generations. It is like bricks building the road humanity will walk on in the coming century. Therefore, when we say goodbye at the end of this podcast, I hope you carry one thing with you. CHOPS is not just a distant project in space. It is part of the story of ourselves. The story of small creatures daring to lift their heads toward infinity and ask what meaning they hold in the universe. If you feel inspired, continue to join us in the next episodes, for there are still countless cosmic wonders waiting to be told, from the dazzling explosions of supernovae to the black holes that defy every law of physics. And perhaps in some future episode, we will witness together the moment when humanity announces, we have found another Earth. Until then, remember, every time you look up at the night sky, it is not only stars that are shining. Somewhere out there, CHOPS is still tirelessly listening, searching, and whispering to us that the journey of exploration has never ceased. Looking back at the whole story, we see that CHOPS is not merely a small telescope in orbit. It is the embodiment of human intelligence, international cooperation, and the eternal desire to search for life beyond Earth. From images that may seem blurry, CHOPS offers us a clearer path to approach the mysteries of the universe. It teaches us that sometimes what appears to be imperfect may in fact be the key to the greatest discoveries. The mission of CHOPS also reminds us that the journey of exploring the universe is not the race of a single nation or organization. It is a shared journey of all humanity, small beings living on a blue planet looking up at the same sky. Every piece of data CHOPS sends back, every star it observes belongs not only to scientists, but to all of us. Perhaps we will not discover a second Earth tomorrow or next year, but every measurement of light, every detection of a new planet brings us one step closer to answering the timeless question, are we alone in this universe? And perhaps the greatest value CHOPS brings lies not only in detecting exoplanets, but in awakening within each of us hope, curiosity, and a sense of connection with the vast universe. It reminds us that regardless of whether life exists out there, here on Earth, we are already fortunate to be part of the rare miracle called life. Therefore, as we close this episode, I invite you to continue following the upcoming stories with us. The universe still holds countless mysteries waiting to be uncovered. And who knows, on this journey, you may be among the first to hear the groundbreaking news. A new world, like Earth, has been found.